Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at a third part of the various quantum numbers which are mentioned in my opening video. Now in this case, we're going to look at the magnetic quantum number, which is going to form a third bit of discussion on various quantum numbers. Now I've mentioned from our introductory part that basically we're going to describe an orbital using a set of three quantum numbers, and which of course are listed as the principal quantum number, the angular momentum quantum number, and the magnetic quantum number are given as such. Now in this specific case, of course, I also mentioned that we're going to describe an electron using four quantum numbers, and this of course are going to constitute the three which are going to be the principal, the angular, and the magnetic quantum number, in addition to the last one which we are going to give for the spin quantum number. In this particular case, therefore, we are going to look at the aspect of the magnetic quantum number, and therefore it's going to describe some of the characteristics of these two specific aspects of the orbital and the electron, which of course are given on the board. Now I've mentioned that basically for the principal quantum number, this was going to describe what we refer to as the distance between the electron and the nucleus. And in this case, we had considered hydrogen-like species, which we had looked at in our previous discussion on the concept of perhaps the atomic radius, which we had given. So basically, I've just given this one in terms of my representation, whereby this one was given in terms of the square of n over z, whereby this is going to be the principal number which are measured. Now in this case as well, we said that we can describe energy in terms of this principal quantum number, and this one was given as a negative value of z over n squared times a value of this one. So we're going to perhaps find a variation of this in description of energies, and these are going to be kilocalories per mole given as such. Now in this case, these are going to be described using various aspects of this principal quantum number. And of course, I mentioned that for the angular quantum number, this is going to be telling us specifically about the shapes and orientation of the orbitals and their various energies, whereby we are given the energies of various orbitals in an ascending order using this specific, of course, arrangement. And I've given it using this specific arrangement, whereby the S is going to consist of lower energies compared to F subshell. Now in this case, for the magnetic quantum number, this was proposed by, of course, Zeeman, and this is going to be described in some of our videos concerning the Zeeman effect, which we are going to see. Now this Zeeman effect, of course, was described by Peter Zeeman, and of course, who was a Dutch physicist, and Heinrich Lorentz. So they together with Zeeman, this received a Nobel Prize for their description of the Zeeman effect, and of course we're going to see that one later in some of our theoretical description videos on the concept of quantum mechanics. Now in this case, this number was described by the, of course, or proposed by Zeeman, and it's denoted using this specific letter over m subscript L given as such. And of course, it's going to give the permitted orientation of subshell. Just this one, permitted orientation of subshells. And of course, this is going to be given in terms of this m which I've given. Now the values of m are going to vary between the value of the angular momentum quantum number of negative L to positive L, and this is going to be through 0. So therefore, we are going to consider this specific aspects of this magnetic quantum number being described using the negative and positive values of L through these specific values of L. Now this concerning the Zeeman effect, which I've mentioned, of course, this is going to be giving us more information on splitting of spectral lines in the magnetic field, and of course this is going to be described using the Zeeman effect, which I've just mentioned in my previous statement. Now we're going to see that for a given value of the value of n, which is a principal number, which of course I mentioned in my opening statement. The total value of the magnetic quantum number m is going to be given in terms of the square of m given as such, and therefore this is going to give us somehow an algebraic relationship between the two numbers for the principal number and the magnetic quantum number given as such. So therefore we can as well give a relationship between the value of the angular momentum number, which we had given in terms of L, whereby we're going to see that for the given value of L as well, we can give a version of the value of M given in terms of 2 into 2L plus 1. And this is going to give us, so basically it's going to be 2, this is going to be 2L plus 1. But it's, so let me just put it in this specific order. So for a given value of the angular momentum quantum number, we're going to have the value of M given in terms of 2L plus 1 given as such. And of course, that's going to give us the relationship between the angular momentum quantum number and this specific magnetic quantum number. So basically, this is going to be a derivative of the previous angular momentum quantum number, which we had discussed. And of course, we're going to see that specifically, we're going to see the various concepts which are going to be developed from this specific relationship, which of course I had given in a tabular form from my previous video, specifically concerning the angular momentum quantum number. Now I'm going to put the specific link of that video in our description box. It's going to be content in terms of a playlist. Kindly check that one so that we can be able to have this additional information from there instead of us repeating of course, on the board. That's going to be summarized in a tabular form, and that's going to be effective for us in trying to understand the implication of the magnetic quantum number and the other two quantum numbers for the principal and the angular momentum quantum number, which we have already looked at. So that is it for now, guys. Bye, God bless you. Kindly check our description boxes as I've said, and subscribe to our channel for more details on various discussion in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.